Imagine trying to bake a cake without knowing how much flour, sugar, or eggs to use. Every time you baked it, you will get a completely different result. Fortunately, nature doesn't work that way. When substances react, they follow precise rules. These rules are so reliable that chemists can predict the products of a reaction before performing the experiment. But how did scientists discover these patterns? Over many years, scientists carefully measured masses, volumes, and composition of substances. What they found out changed the chemistry forever. They discovered that matter combines according to fixed laws. These laws are known as the laws of chemical combination. In this lesson, we are going to explore the 6 important laws, and this includes the law of conservation of mass, the law of definite proportions, the law of multiple proportions, law of reciprocal proportions, the Gay-Lussac's law of combining volumes, and lastly, the Avogadro's hypothesis. And by the end, you will see that all chemical reactions follow these simple but powerful rules. Let's begin with the most fundamental laws in chemistry. Suppose you burn a strip of magnesium ribbon, a bright white flame appears. The magnesium seems to disappear. Many people will think that some mass has been lost. But has it really? The answer is no. The magnesium atom simply combines with oxygen atoms from the air to form a new substance called magnesium oxide. Nothing is lost, nothing is gained. The atoms are merely rearranged. This observation led Anthony Lavoisier to propose the law of conservation of mass. The law states that mass can neither be created nor destroyed during a chemical reaction. In other words, the total mass of reactants equals the total mass of the products. Let us see this with numbers. Consider the reaction of magnesium and oxygen to get magnesium oxide. To balance this, we shall have 2 before magnesium and 2 before magnesium oxide. Suppose we have 48 grams of magnesium and 32 grams of oxygen. The total mass before the reaction is 48 plus 32 and it gives us 80 grams. After the reaction, 80 grams of magnesium oxide are formed. Notice something remarkable. The mass before the reaction is exactly equal to the mass after the reaction. Nature keeps perfect records. Every atom that starts the reaction must appear somewhere in the products, and that is why balancing chemical equations is so important. Balanced chemical equations are simply mathematical representation of law of conservation of mass. Let's look at this example. A student burns 9 grams of hydrogen gas in 72 grams of oxygen gas. Water is produced. What mass of water is formed? Since mass is conserved, mass of water equals 9 grams plus 72 grams, which equals 81 grams. Simple, right? The total mass never changes. Now let's move to another fascinating observation. Imagine collecting water from 3 different places. One sample comes from a river, another comes from rain, a third comes from a laboratory. Although these samples come from different places, they all have the same chemical formula, which is H2O. Scientists wanted to know whether the ratio of hydrogen to oxygen was always the same. And after numerous experiments, they discovered that it was. Every pure sample of water contains hydrogen and oxygen in exactly the same ratio by mass. And this became known as the law of definite proportions. The law states that a pure compound always contains the same elements combined in the same fixed ratio by mass regardless of its source. Let's examine water. Hydrogen has an atomic mass of 1. There are 2 hydrogen atoms, therefore 2 multiplied by 1 equals 2. Oxygen has an atomic mass of 16, therefore the mass ratio becomes 2 to 16. Simplifying this, we get 1 to 8. No matter where the water comes from, the ratio remains 1 to 8. That ratio never changes. Let's look at an example for this. Scientists performed 2 experiments using copper and oxygen. Experiment 1, copper mass was 3.18 grams and oxygen mass was 0.80 grams. The ratio shall be 3.18 divided by the smallest value, which is 0.8, and this equals approximately 3.98 to 1 as the ratio. Experiment 2, copper mass was 7.96 grams and oxygen mass was 2.00 grams. The ratio shall be 7.96 divided by 2.00, and this equals approximately 3.98 to 1 as the ratio. Both experiments produce exactly the same ratio, and this proves that copper oxide always has the same composition. Now let's look at the third law, that is the law of multiple proportions. The previous law showed that a compound has a fixed composition. But what happens when the same two elements form more than one compound? Scientists notice something interesting. The masses of one element that combine with the fixed mass of the other always occur in simple all number ratios. This observation became the law of multiple proportion. Let us use nitrogen and oxygen. Nitrogen can form nitric oxide, that is NO, and nitrogen dioxide, that is NO2. For NO, nitrogen is 14 grams and oxygen is 16 grams. For NO2, nitrogen is 14 grams and oxygen is 16 multiplied by 2, and we get 32 grams. Notice that the mass of nitrogen remains fixed at 14 grams. The oxygen changes from 16 grams to 32 grams. The ratio becomes 16 to 32, which simplifies to 1 to 2. And this is a simple all number ratio, and this is exactly what the law predicts. The same pattern appears throughout chemistry. Nature prefers simple mathematical relationships. Next, let us look at the law number 4, which is the law of reciprocal proportions. This law sounds intimidating, but is actually quite logical. Suppose two elements combine separately with a fixed mass of a third element. The masses of those two elements will either be the same ratio or a simple multiple of the ratio in which they combine with each other. Let's use carbon, sulfur, and oxygen. Carbon forms carbon dioxide, sulfur forms sulfur dioxide. For carbon dioxide, the ratio of carbon to oxygen is 12:32. For sulfur dioxide, the ratio of sulfur to oxygen is 32:32. Using the same mass of oxygen, we compare carbon and sulfur. The ratio of carbon to sulfur is 12:32, and this simplifies to 3:8. Now consider a compound formed directly between carbon and sulfur. The ratio between carbon and sulfur is found to be related by a simple all number relationship. Again, chemistry reveals a hidden mathematical pattern. Law number 5, the Gay-Lussac law of combining volumes. Until now, we focused on mass. Now let's look at volume. French scientist Joseph Gay-Lussac discovered that gases react in simple volume ratios. And this law states that when gases react, the volumes of reactants and products bear simple all number ratios provided temperature and pressure remain constant. Consider ammonia formation. Nitrogen plus hydrogen gives us ammonia. To balance this, we shall have 3B for hydrogen and 2 before ammonia. Notice the volume ratio. 1 volume of nitrogen reacts with 3 volumes of hydrogen to produce 2 volumes of ammonia, and the ratio is 1 to 3 to 2. Suppose we have 40 ml of nitrogen and 120 ml of hydrogen. The reaction produces 80 ml of ammonia. Again, simple all number ratios appear. This is not a coincidence. Scientists observed this behavior repeatedly. Let's look at the last law, Avogadro's hypothesis. One question remained unanswered. Why do gases combine in such neat volume ratios? The answer came from Amedeo Avogadro. He proposed a revolutionary idea. Equal volumes of all gases contain equal numbers of molecules provided temperature and pressure remain constant. Think about these 3 containers. One contains 100 ml of hydrogen, another contains 100 ml of oxygen, and the third one contains 100 ml of ammonia. The gases are different, the molecules are different, but if the temperature and pressure are the same, then all the 3 containers contain exactly the same number of molecules. This idea became one of the foundations of modern chemistry. It eventually led to the mole concept, molecular formulas, and much of the chemistry studied today. Now let us bring everything together. The law of conservation of mass tells us that mass is never created or destroyed. The law of definite proportions tells us that compounds always contain elements in fixed mass ratios. The law of multiple proportions explains why the same elements can form different compounds using simple whole number ratios. The law of reciprocal proportions reveals the relationships between elements that combine through a common element. Gay-Lussac's law shows that gases react in simple volume ratios, and lastly, Avogadro's hypothesis explains why those volume relationships exist. Together, these 6 laws transformed chemistry from observation into a precise science. Every balanced equation, every mole calculation, and every chemical reaction you study today is built upon these discoveries. Chemistry may seem complicated at first, but beneath every reaction lies a simple truth: nature follows pattern. And the laws of chemical combination are some of the most beautiful patterns ever discovered. If you understood this lesson, try answering this question. Nitrogen forms 2 compounds with oxygen. One contains 16 grams of oxygen and the other contains 48 grams of oxygen for the same mass of nitrogen. Which law explains this relationship? Pause the video and think about it. The answer is the law of multiple proportions. If you got it right, you are already thinking like a chemist. And that is all for today's lesson. Don't forget to like this video, comment, share, and subscribe to our channel. Thank you for watching this video.